Okay, this recording is strictly for the football dilemma, which is class activity 1, which is going to be one of your 9, 10, or 11 assignments. I don't know how many assignments we're going to squeeze in this quarter, but we're going to try. So, class activity number 1. It's an important moment for Miss Kruger's favorite college football team, the Notre Dame Fighting Irish. It's the last few seconds of a play, and the Irish are down by 5 points against their arch rivals, the Michigan Wolverines. Notre Dame has the ball on Michigan's 3rd-yard line. If they can get a touchdown, they'll win. Can the Irish do it? Think of the football field's huge coordinate plane. Each small square represents 2 yards. That's important information. Notre Dame's quarterback is standing at 32-4. So we're going to have to plot 32, 4, 2, 4. So this is the quarterback for Notre Dame. And throws a pass. Every quarter of a second, the ball moves 4 yards west and 3 yards south. Graph the ball's progress on the field. So every quarter of a second. So that's 1/4 of a second. Time 0.25. So 4 yards, northeast, west, south. What is it again? For all of you that get confused. Never eat slimy worms. Something like that. So 4 yards west is really this direction, and 3 yards south, of course, is down. So from here, he threw the ball 2, 4, and then 3 yards down, 2, 1. Here's the ball. That's 1/4 of a second. And then I'm going to go down, or over 2, 4, down 1, 2, 3. And then over 2, 4, down 2, 3. So if this is 1/4 of a second, 2 quarters, 3 quarters, I need one more to make 1 full second. Down 1, 2, 3, and over 4. So this is 1/4, 2/4, 3/4, 4/4. So here's 1 full second of the ball. Now I could continue it on. Down 3 over 2. Down 3 over 2. Down 3 over 2. And then I could just kind of sketch in a line here. That's the path of the ball. And I said that this was at 1 second. At the moment the quarterback throws, the receiver is at 26, -14. So I have the receiver 26, 2, 4, 6, and -14. 2, 4, 6, 8, 10, 12, 14. Here's the receiver. Every quarter of a second he moves west 3 yards, so 2, 3, and north 1 yard, up 1. And then 1, 2, 3, up 1. Up 1, and then over 2, 3, up 1, 1 and over 1, 2, 3, up 1 and over 2, 3. So I can sketch the line here. Oh, he's starting here, he wouldn't go further back. Here's the receiver. Will the player's path cross the ball's path? Well, based on our graph, yes. Can you definitely tell whether the player and the ball will cross the paths at the same time? So time is important here. Are they crossing at the same time? So no. We can't tell. Not sure. I'm not sure. So to be sure, we could plug in a table, which is what's provided for you on the next page. And you're going to need to write an equation for your parametric equation for x was something times t plus your intercept. And for your y, something times t plus your intercept. So for x, for the quarterback, fill in the following table of values for the football's x and y progress. So this was from the quarterback when they threw it. I should keep it with black, sorry, since I made the quarterback. Drew his path in black. So at time 0, he was at 32.4. And at time 0, the receiver, I'm just going to fill in, was at 26 and negative 14, I believe. And then for the ball, he went down 3, or sorry, back 3, so negative 3. And, oops, moves 4 yards west, so negative 4. And down 3. Somebody's been playing with my whiteout. Down 4, or I'm sorry, west 4, and down 3. And we can fill in the whole table. So this would be 28, 24, 20, 16, 12, and 8. And if we go down 3, we're at 1, and then negative 2, negative 5, negative 8, negative 11, negative 14. Now we really didn't need to fill in the table this time in order to write the equation, since I already kind of labeled the slope here. But remember, when you're doing it for your x equation, you're covering up the y's and just looking at your t as your x and your x as your y in a way. So the intercept here is at negative, 0 and 32. So this 32 right here is what's coming down here. Now I want the change in t, or change in x over t, so it's going down 4 for every 1/4. That's kind of confusing. So let's just jump it from 0 to 1. As it goes up 1, we're going down from 32 to 16. You went down 16. So negative 16 over 1. Or you could write it as x equals negative 16t plus 32. Obviously, if you put negative 4 over 1/4, you would still get negative 16. I just know for some of you, you hate those fractions. Now I've got to do the same thing, but I need to cover up my x's for a moment and just look at my y's with my t's, if possible. Obviously that pen is a little too fat for that. Almost there. Cover it up somehow so you're just looking at your t's and your y's. The intercept is at 4. That's when time is 0. That's where it starts. And then from 4 to 1, it's going down 12. So negative 12 over 1, which we could rewrite as y equals negative 12t plus 4 as your equation. Now what's going to happen with this is down here, you're going to do the same thing for the receiver. And you come up with your two equations. Then, when will the ball and the receiver be at the same x value? Set both x equations equal to each other and find out. So do exactly as it says. And then when will the ball and the receiver be at the same y value? Set both y equations equal to each other and find out. And then you're just answering, will the ball and the receiver be at the same place at the same time? So in other words, do 7 and 8 have the same t? If you flip to the back, passing didn't work, so obviously they're saying they don't work. Notre Dame's coaches have decided to try the running ball. Quarterback hands the ball to running back at 32.4. Every quarter of a second, the running back runs 3 yards west and 1 yard south. So you need two parametric equations, which means x equals something times t plus your intercept, and y equals something times t plus your intercept. I would definitely make yourself a table with your time, your x, and your y. You could make 2 tables if that helps. And you are going every quarter of a second. You could jump it to 1 second to make it easier. Write 2 parametric, and then we have Michigan's free defender is running to tackle the running back every quarter of a second. He runs 2.5 yards west and 0.5 yards north. So same thing, you're writing 2 parametric equations for the defender, and pretty much the same thing as the other side. Set the x equations equal to each other, set your y equations equal to each other. Are your t's the same? Substitute that time into either x equation to determine where the tackle will occur, who wins the game, y. So this is your class activity assignment number 1. That is going to be part of your grade. If you need more help, please ask during stat time or pre-calc time, or come in during nest. Thank you.